Finding limits graphically and numerically, use a table or a graph, or maybe analytically. If you have a hole or jump, then the limit does exist, but it doesn't if you get a gap or asymptote. Sometimes a limit exists, but only from one side. Is it right or is it left is important just to know. Intermediate value theorem shows you if C exists, but then things are crazy with limits at infinity. We didn't start the calculus, it was always burning since mind was turning. We didn't start the calculus, no we didn't like it, but we tried to learn it. Derivatives help find the slope at a given point. Instantaneous rate of change is another name for that. Constant rule, power rule, and the product rule, they were all pretty easy, at least compared to what's next. Quotient rule, low d high minus high d low, all over the bottom squared, and away you go. Chain rule is pretty cruel. You do the power of the outer, then you take the derivative of the inner, and now you know the rule. We didn't start the calculus, it was always burning since mind was turning. We didn't start the calculus, no we didn't like it, but we tried to learn it. Implicit differentiation and related rates, they're really ridiculously hard. I almost failed those tests, but then we get a break when we get to chapter 3, cause graphing functions is pretty easy. Extrema on an interval, find the criticals, roles, mean value, increasing, and concavity. First test and second test, more limits at infinity. Now we can sketch a curve and then you gotta optimize. We didn't start the calculus, it was always burning since mind was turning. We didn't start the calculus, no we didn't like it, but we tried to learn it. Antiderivatives, integrals, they are indefinite, the reverse of chapter 2, and you got a plus C. Now we find the area using some rectangles. It's the area under the curve, and we know how to approximate. Riemann sums are definite, the fundamental theorem of calculus, substitution, trapezoids. What else do I have to say? We didn't start the calculus, it was always burning since mind was turning. We didn't start the calculus, no we didn't like it, but we tried to learn it. Natural log's derivative and integration, inverse functions, exponential. Derivative of e to the x is itself compound, interest functions bases other than e. Inverse trigonometrics, we never learned that area between two curves, you gotta subtract. Find the volumes of discs and cross sections. L hop the limit, and now you've mastered calculus.
We didn't start the calculus, it was always burning since mind was turning. We didn't start the calculus, but when we are gone, it'll still get taught on and on and on and on.
We didn't start the calculus, it was always burning since mind was turning. We didn't start the calculus, no we didn't like it, but we tried to learn it. We didn't start the calculus, it was always burning since mind was turning. We didn't start the calculus, no we didn't like it, but we tried to learn it.